Hello students, welcome to my YouTube channel Physics with Sir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please press the like button. And this gives more motivation so that I can bring more number of videos for you. Today's topic is projectile motion. It's a very important chapter for JEE, Neet, Advanced, etc. Correct? So let me start the chapter. Please listen to the concept very carefully. Here I'm going to show you how to handle the problem related with these chapters and the basic theory of the chapters. Correct? Projectile motion is actually nothing but motion in 2D. Correct? It's actually motion in a plane includes both vertical motion and horizontal motion. Clear? So let me tell you what do you mean by projectile. Think for a moment the situation like this. Suppose a footballer kicks a football like this. Correct? So what will happen to the football? It will follow a path like this and ultimately falls to the ground. This kind of motion is called projectile motion. Some of the important things you have to know: the velocity with which we are projecting this football or a particle or a body, or it may be anything, correct, is called initial velocity of projection. This angle is called angle of projection. Clear? In projectile motion, actually, two kind of motion are there. Number one, motion along x-axis as well as along y-axis. So what will happen? Because of the action of gravity, G will act along this direction. Clear? One thing you have to remember in this case, in case of projectile motion, it is nothing related with engine, correct? It is under the control of gravity, correct? Now, and we are not considering any kind of air resistance in this case. Clear? Now, the path along which the projectile travels, correct, it is called its trajectory. Okay. So, one by one, I am going to show you all the information related to this. But before going to start with this, let me tell you a few of the informations related to this chapter. Before going to proceed any kind of thing related to this chapter, I am going to tell you something. Anything, suppose this is the throw level, correct? It is the throw level. Suppose from this is the point of projection. If anything goes around this direction, x is considered to be positive. If anything goes around this direction, we'll consider x as negative. And if anything goes up, we'll consider that positive y. And if anything goes down, we'll consider this negative y. Okay. But you have to keep remembering one important thing in this case. This is the thing which we have to consider in this case, because there will so many situations will come where we have to apply all these things together, correct? Now, this is nothing new. It is just a Cartesian system, Cartesian coordinate system, and I am going to apply the rules of the Cartesian coordinate system. Clear? Now, what will happen? Look, this particle is moving up. Why this is moving up? If you look at this equation, this particle is moving up as well as going along horizontal direction also. So why this kind of motion is taking place? Now look at this. If I resolve this velocity into component, correct? And one velocity along this direction. We know the angle with which the vector makes an angle, the velocity vector makes the angle, correct? So this means side with which velocity vector makes an angle, that would be the cos component. and the other normal component would be the sine component. Now, in this case, since air resistance is neglected, no force is acting along x-axis, correct? Since no force is acting along x-axis, since no force is acting along x-axis, okay, motion along x-axis is motion with uniform velocity. Okay, and since along the direction of y-axis, it is under the control of gravity. So motion along y-axis is uniform accelerated motion. So this thing you have to keep in mind, correct? The motion along x-axis is with constant velocity and motion along y-axis is with constant acceleration, that is g. Okay. Now, in the video of vertical motion under gravity, I told you this, key g is such kind of thing which always acts downward, correct? So what will I do? I am going to write down some of the important things, correct? Look at this. Which formula when we have to use, correct? When it is the motion along x-axis, since no force is acting, we'll apply this formula, ux equal to vx. That means velocity along x-axis is always constant. So in order to find out displacement along x-axis, I apply either ux into t or vx into t, where t is the time during which this displacement occurs, correct? Now, for motion along y-axis, what we do? We have to apply this formula. Look, vy equal to uy, correct? Plus minus g into t. Why? Because g always acts downward, correct? Whether it is going up or down, correct? Next, v square equal to u square plus 2 minus g into h, okay? And h equal to ut, uyt plus half at square. And this is obviously along which axis? Along y-axis, correct? So the time taken by this to reach the maximum height, time taken to reach the projectile to reach the maximum height is called time taken to reach maximum height. But the time taken by the projectile to complete its entire journey is called total time of flight or simply time of flight. So remember some of the important informations. Okay. Maximum vertical displacement of the projectile is called maximum height. Okay. Number 2, maximum horizontal displacement is called range of the projectile, or simply range. Time taken to complete the journey is called time of flight. Okay. And the equation of the path followed by the projectile is called equation of trajectory. Okay. So these are the things which you have to keep in mind, correct? And I am going to start deriving all this formula. Later on, I will show you how to solve problem without remembering the formula, correct? Okay. Now, one thing I want to tell you here, look, as the body goes up, the vertical velocity slowly decreases. But as I said, no force is acting along the x-axis, so velocity along x-axis is constant. So what happens at the maximum height? At maximum height, only one velocity exists, velocity component exists, and that is what? The horizontal component, correct? You can say it ux or vx, whatever you like. But vertical component of velocity at the highest point is 0. Clear? Always remember one thing. Why this horizontal component is not 0? If this horizontal component and vertical component both become 0 at this point, instead of following this path, projectile will straight away fall to the ground. Clear? So remember, these are the important things, correct? Now I'm going to derive the formula for the projectile motion. Clear? But I will prefer key, instead of learning this formula previously, means preliminary, at least you try to solve by using construction. Later on, you can remember the formula for solving the problem in a faster manner, correct? So now, projectile motion, suppose a body is projected from a point. Always take the point of projection as the origin. Okay, this will help you to do the calculation, right? Taking this along x-axis, this along y-axis, and this is the point of projection, let it be O. And suppose it is projected with a velocity u. With a velocity u. I told you this velocity is called velocity of projection, and this is theta. Clear? Now I am going to split this velocity into two different components, one along the x-axis, other along the y-axis. Now let me write down this component as ux, that is u cos theta, and this is uy, which is u sin theta. Now what will happen? Because of the action of both the component, projectile will travel in horizontal direction and simultaneously it will move along the vertical direction. So it will follow a parabolic path like this. Okay, later on I will show you why the path looks like this by doing the mathematical derivation of the path, correct? Now, first, let me write down the information. Initial velocity along x-axis is u cos theta. Initial velocity along y-axis is u sin theta. always remember one important thing. For horizontal motion, use the horizontal components, and for vertical motion, always use the vertical component. Correct? Now, let us try to find out first the maximum height reached by the projectile. So, this is the maximum height reached by the projectile. Okay. So, let me write it. Small h is the maximum height. Okay. And this is what? Motion along y-axis. Correct? So, maximum height. I told you this earlier also. For horizontal direction, any kind of motion related with the horizontal direction, use horizontal component. Any kind of motion related to the vertical component, vertical direction, use vertical component. Now, this is along which component? Obviously along y component, because it looks parallel to y-axis. So, I'm going to use the formula for the vertical motion. And I told you this, for vertical motion, we can apply these three formula. Sy equal to uy plus half ay t square, number one. Vy equal to uy plus ay into t. Ay into t. And vy square is equal to uy square plus 2ay sy. Now, one interesting thing is this, as I told earlier, at the highest point of the path, the vertical component of velocity is 0. That means Vy is equal to 0. And I am trying to find out the maximum height. So I want to apply this formula, Vy square equal to Uy square plus 2ay into Sy. Okay. Now, why I am writing this again? So I can tell you which sign when we have to apply. Since Vy is 0, put 0. Now Uy, as I told you, anything goes up from the point of projection, you have to consider that as positive. So in this case, Uy is positive, and that is nothing but U sin theta. Plus, as I told you, small g always acts vertically downward. So what you have to write, this is minus g. And Sy is what? Vertical displacement. Look, it is above the level of throw. So it is also positive. So if I simplify this, the result is coming h is equal to u square sine square theta by 2g. The shortest way of remembering this, u sine theta is nothing but the y component. Okay, so write it like this, uy square by 2g. This is the technique of finding the maximum height. Number two, how to find out the time of flight. Or first, let me do one thing that is much interesting. Time taken to reach the maximum height. Okay. What is the time taken to reach the maximum height? So for the time taken, I am telling you time taken to reach the maximum height. That means at a vertical direction. So I'm going to use this formula. Vy equal to uy plus ay into t. Okay. Now, Vy is what? At the maximum height, vertical component of velocity is 0. Uy is, look, u sine theta. And ay is minus g. And let me consider t prime as the time taken to reach the maximum height. So t prime is equal to u sine theta by g, or you can write it like this, uy by g. Is it clear? Now, let us try to find out the time taken to complete the journey, that is time of flight. Now, for time of flight, what I am doing here, okay, Let us consider the vertical motion. Okay, if you watch it, it goes up, reaches to a maximum height, is the maximum displacement on the y-axis, again comes down, and at this point it becomes what? At this point, where it strikes the ground, its vertical displacement is 0. So what I am going to do here, I am again going to consider the vertical motion, correct? But in this case, what I am doing, I am using this formula. Sy is equal to uyt plus half ay into t square. Now, Sy is what? From this point, suppose this point A, which is the point at which projectile touches the ground. At O and A, if you look at this, okay, the y component of both of these, when the y coordinate of both of these are same, that means vertical displacement is 0. So what we can write, Sy equal to 0, Uy is u sine theta. Let us consider capital T is the time of flight, plus half A is replaced by minus g, and this is t square. Now, let me do one thing better. Take t common. If I take t common, it is u sine theta minus half g t is equal to 0. Let me put a line. Okay. T cannot be equal to 0. Obviously, it cannot be equal to 0 because if t is equal to 0, what will happen? If t equal to 0, that means the time when it started its journey, correct? So t cannot be equal to 0. So here, what will happen then? If t cannot be equal to 0, therefore u sine theta minus gt is equal to 0. Therefore, t is equal to, sorry, half gt. T is equal to 2u sine theta by g, which is nothing but 2uy by g. Now, if you follow it, you can find out easily that t equal to twice of t prime. That means time taken to reach the maximum height. In the same time, it reaches the ground again. That means time of flight is twice the time taken to reach the maximum height. That means in this case also, time of ascent is equal to time of descent, correct? Now, how to find out the range of the projectile? Okay. How to find out the range of the projectile? Look at this. For range, what is called range? I told you the maximum displacement along which axis? It is along the x-axis. So range is actually the separation between O and E. O and E. So what I am doing here, for range, which component I have to use? X component. And I told you the motion along x-axis is always in this case constant. So you have to apply this formula, Sx equal to Vx t, or you can apply Ux t because Ux equal to Vx in x-axis. So I am just applying Sx equal to Uxt. Okay. Now what is Sx? What is Sx? Sx is nothing but range. Why it is plus? Because look, it is towards positive x-axis. Ux is what? Plus or minus? It is towards positive x-axis. That means u cos theta. And in this case, small t is what? It is nothing but the time of flight. So r equal to u cos theta. Okay. Let me write it like this first. T is equal to what? 2 u sine theta by g. Okay. Now, the simple technique of remembering this, 2 u cos theta is ux, u sine theta is uy by g. This is the formula for the range. Now, I can simplify the formula more. Okay, let me simplify it again. Okay, and let me convert into the general formula. Okay, but technique of remembering is this: 2 ux into uy by g. What is r? R is equal to 2 u square, and we can write it 2 sine theta cos theta. And you people are quite familiar with this formula. This is the formula of some multiple angle, and this u square sine 2 theta by g. So this is the basic formula in projectile motion. Okay, so these are the basic formula. Nothing to do more with this, correct? Now, I am going to show you a few of the application related to projectile motion. So, let me draw the first application. So, this is a problem given. A projectile is projected like this with a speed of 20 meters per second, making an angle 37 degrees with the horizontal. We need to calculate time of flight, maximum height, range of the projectile, the velocity with which it hits the ground. Correct? So, first of all, let me split it into two components. 20 cos 37. Cos 37 is what? It is nothing but 4 by 5. 5 fours are base 16 meter per second. So ux is 16 meter per second. What about ui? That is 20 sine 37. Sine 37 is 3 by 5. 12 meter per second. So ui is 12 meter per second. Clear? Now time of flight. How to calculate? What is the formula? 2u sine theta by g. In shortcut we can write it 2ux by g. What is 2ux? Ux means 16. Correct. Sorry, 2ux, not 2uy. Sorry, 2uy by g. 2uy by g. So what is 2uy? Uy is 12 by g is 10. Okay, it is 24 by 10, 2.4 seconds. Okay. Number one, number two. What is the maximum height reached? Formula for the maximum height is u square sine square theta by 2g. U sine theta means what? Uy, that is 12 into 12 by 2 into 10. Cancel. 6 12s are 72 by 10, 7.2 meter. What is the range of the projectile? R is equal to u square sine 2 theta by g, or in short you can write it ux into uy by g multiplied by 2. 2ux uy g. Correct? 2, what is ux? 16. What is uy? 12. What is g? 10. So 6, 12 to 0, 24 into 16 is what? 24 into 16 is equal to 24 by 10. That is 38.4 meter. Okay. The last question is, what is the velocity with which it will hit the ground? Correct? So let me solve this part. Okay. Now, time of flight is 2.4 seconds. This I require. Okay. Time of flight is 2.4 seconds. So that is t equal to 2.4 seconds. So do it like this. Look, if I draw a tangent at this point, it hits the ground like this. It has two components of velocity, one along this direction, other along this direction. Correct? Let me write this as Vx and this as Vy. Okay. Now, what is the value of Vx? As I told you, it is the velocity along x-axis which remain constant throughout. So we can write Ux equal to Vx, and that is nothing but 16 meter per second. Now, what about Uy? What about Uy? Correct? So I don't know the sign of Vy. I don't know the sign of Vy. Let me do it. I will find it from this. Correct? Okay, watch it. I am going to use this formula. Vy equal to Uy plus Ay into T. Vy I need to find out. What is Uy? Velocity along y-axis. That is what? 12 meter per second. 12. What is Ay? Ay is minus g, that is minus 10, and time of flight is 2.4. So let me do the calculation first. 12. Okay. 2.4 into 10, it is 24. That is minus 12. Correct. What is the sense of minus 12? That means velocity is in downward direction. So what is the resultant velocity V? V is equal to root over of Vx square plus Vy square. What is Vx square? Vx equal to 16, that is 16 square plus 12 square. 16 square is 256, I think. 16 square is 256. And 12 square is 144. 256 plus 144 is 400. Correct? So it is 20 meter per second. And you can say the angle also. What is the angle? You can find out with this angle, okay, or with this. Correct? So this angle you can say is it is theta. Tan theta is equal to take this is Vx height by base, Vx by Vy, and what is Vx? Vx equal to 16 and by 12, magnitude 4 by 3, that is theta is equal to 53 degree. Okay, and if you calculate this angle, 37 degree, that means the angle with which it is projected, it will strike the ground with the same angle. Correct? So this is a very, very interesting problem. Now I'm going to show you the equation of trajectory of the projectile. Correct? Equation of trajectory of the projectile. So how to find out the equation of trajectory? Okay, equation of trajectory. Look, this is the diagram. Projectile is projected with the speed velocity u. Ux is the component along x-axis, uy is the component along y-axis. It is following a path like this. Correct? Now, say for example, at any instant, the projectile reaches at this point, which is a general point, and let this point be P. Let this point be P, and let this gap is x, and this height is y. So, what is the coordinate of this point? X comma y. That means vertical displacement is x, and horizontal displacement is x, and the vertical displacement is y. So let t be the time after which the projectile reaches at this point. So what is the value of x? So let me apply motion along x-axis. Sx equal to ux into t. Sx is s, ux is u. What component? Cos theta into t. Because I said this earlier also, this is u cos theta and this is u sin theta. This is x-axis, this is y-axis. Now this is, therefore we can write t is equal to x by u cos theta. This is equation number 1. Now, trying to find out the motion along y-axis, correct? So what you have to do? So let me apply this formula. Sy equal to uyt plus half ay into t square. What is sy? It is y. What is uy? It is u sin theta into t, clear? Plus half ay should be replaced by minus g into t square. So y equal to u sine theta into t minus half g t square. Clear? Now what I'm going to do, look, I need to find out the relation between x and y. That is a parameter, correct? I need to replace this parameter. So what I'm going to do, I'm just replacing t from equation 1 in equation 2. Y equal to u sine theta. T is equal to x by u cos theta minus half g t square is x by u cos theta whole square. So if I simplify the result, this get cancelled. Y equal to x tan theta minus half gx square by u square cos square theta. Correct? Clear? So this is what we call the equation of trajectory. Now, if you compare this with the standard equation, correct? It is like this: ax and plus x square plus bx plus c. It is the equation of it is the quadratic equation, which is the equation of a parabola. That is why the path of a projectile is always to parabola. Correct? Now I can modify the relation in that. Okay, I can represent this equation of trajectory even in terms of range also. So what is that? Take x common from this equation. If I take x common, what will happen? Or let me consider take x tan theta common. 1 minus half g x by u square cos square theta. If I take tan theta common, so what I have to do? I have to multiply tan theta with this. Because if you multiply with this, the result becomes unchanged, correct? Now, x tan theta half 1 minus half gx u square cos square theta. Tan theta is what? 2 sin theta by cos theta. Sin theta by cos theta. So 1 cos theta can get cancelled with this. And if it gets cancelled, so I can replace this in this one. So y equal to x tan theta 1 minus x tan theta one minus, look, g, writing it like this, x by u square 2 sin theta cos theta by g. Correct? So it is nothing but the formula for range. So this is the representation of equation of trajectory in terms of range. X tan theta 1 minus x by r. Okay, so this is the equation of trajectory of the projectile in terms of range. Correct? Now let me show you one application of the equation of trajectory. Okay, so let's solve a problem. Suppose a projectile is projected making some angle theta with the horizontal, and there is an inclined plane, and projectile is projected from one side of one of the vertex on the base of the incline. Correct? It touches the top, okay, of the incline, and one is grazing the vertex and reaches the point C. So the question is, a projectile is projected from one side of the base Okay, a problem is given like this. A projectile is projected from one side of the base of an inclined plane. It is the inclined plane ABC. Grazing the vertex, it reaches the opposite side of the base. Means here. Prove that tan theta is equal to tan alpha plus tan beta. So how to solve this problem? Correct. Look, what I am doing, taking this point, it is not necessarily be maximum height. Okay, any point. Let us assume the coordinate of the point is x comma y. So it is simply the height of the height at which the vertex is there, y, and this is x. So remaining is obviously r minus x. Now what I'm doing, I'm considering the triangle. Let me write down this as D, ABC. So in triangle ABC, what I can write, tan alpha is equal to height by base. That is y by x. Y by x. And in this another triangle BCD, what I can write, tan beta is equal to height by base. That is y by r minus x. Now tan of alpha plus tan of beta is equal to y by x plus y r minus x. Now do one thing, take y common. So what I can write, r minus x plus x divided by x into r minus x. If it is so, x as it cancelled. So it is yr by x into r minus x. Now what we know from the equation of trajectory, y equal to x tan theta 1 minus x by r. Now let's simplify this. Okay, y equal to y by x equal to tan theta r minus x by r, which is equal to tan theta ry divided by x r minus x. So this is equal to tan theta. Proved. It's an important application of equation of trajectory. Correct? So next topic is the horizontal projectile. That means when the projectile projected horizontally. So for that, continue to watch my next video. Good day.